Hi. Engineers face a decision to make in selecting the topology of a power supply during the start of a project. So let's talk about high efficiency topology selection for applications requiring 100 watts to 250 watts for DC to DC stage. We are showing the active clamp flyback and LLC half bridge resonant topology, and we have also listed some of the key factors for consideration of power supply development. The first and foremost is the DC to DC efficiency. In active clamp flyback, the primary leakage energy gets stored onto the clamp capacitor, delivering it to the output when the transistor is in off during the switching cycle. On the other hand, LLC half bridge, the half bridge basically excites the resonant tank, creating a sinusoidal waveform. In both of these designs, the switching losses are reduced due to zero voltage switching. So with respect to active clamp flyback, we have seen the efficiency to go till 97%. On the LLC, it's 1% higher with 98%. So both of these designs are highly efficient in these considerations. Let's move to the compliance to EMI. So in active clamp flyback, we could see that the sudden cutoff of the primary current gives rise to a huge voltage spike on the primary switching transistor, which poses a challenge for EMI considerations. On the other hand, in LLC half bridge, there is a single fundamental frequency due to the sinusoidal nature of the LLC, making it wait for EMI considerations. So with respect to compliance to EMI, LLC is the way to go. One of the key factors is the component stress. So we have listed the drain current comparison between active clamp flyback and LLC half bridge resonant topology. The high drain current spike can result in a high voltage stress on the active clamp flyback primary switching transistor. So due to this reason, the ACF designs typically need a high voltage switch rating of at least 750 volt. On the other hand, the LLC half bridge resonant topology with respect to the switch current, due to its sinusoidal nature, it typically needs 550 volt. So with respect to component stress, we will go with LLC. So let's look at how complex both the designs are. In active clamp flyback, there is a single primary switch and a single SR control, so making the design much more simpler. On the other hand, in LLC half bridge, engineers more often need to manage the resonant tank with LLC values as well as the transformer for the LLC stability, making the design relatively complex. So with respect to the complexity, we will go with ACF to be much simpler. Now let's move on to the size of the components for active clamp flyback and LLC half bridge design. In active clamp flyback, we could see that increasing the switching frequency of the primary switching transistor poses a challenge with respect to EMI, as well as a trade-off on maximizing the efficiency. On the LLC half bridge resonant, we could see that due to its sinusoidal nature, increasing the switching frequency makes way for reduced transformer size, making it much more smaller and lighter. So with respect to the sizing on a comparative level, LLC wins. Now let's look at the no-load input power to satisfy some of the standby requirements. In active clamp flyback, due to its wide input range of operation, the power factor correction stage could be turned off. So on the other hand, the LLC half bridge resonant topology, due to its operation in a certain DC bus range, the PFC is always on, which makes way for the ACF flyback to be having reduced no-load input power. So ACF wins here. As you could see, the selection of power supply topology depends upon the requirements specific to the application and proper choice of components. In consideration of all these factors, designers could select the topology in order to meet their needs. Power Integration's InnoSwitch 4CZ, HyperLCS2, and HyperPFS5 comes with high level of integration with high voltage switch, synchronous certification, and flux link feedback, all in a compact package. For more information, visit power.com. Thanks for watching.